In class example 2.27, we will relate a graph to the remainders and factors of a polynomial function. Unlike some of our previous examples where we're given the polynomial function, here we're just told that it's called p of x, and then we have a graph of degree 3. It confirms that the leading coefficient of the function will be a 1, and it has integral zeros. We'll talk about the leading coefficient in a little bit, but the integral zeros means that each x-intercept we see there happens at an integer number. So -2, +2, and positive 3 are the x-intercepts. There's no chance that it is at 2.1 or 3.4. They are exactly on the integer values. At first, we're asked to use the points given to us to determine the remainder when we divide p of x by x plus 2. Well, you might be thinking, I don't have the equation. I can't use synthetic division. I can't even use the remainder theorem to evaluate. But if we could use the remainder theorem, what would we be evaluating? Well, to divide by x plus 2, we would be evaluating the polynomial function at x equals -2. We know on the graph that x equals -2 is one of our x-intercepts. This means that p of -2 is 0. And so the remainder, when we divide by x plus 2, would also be 0. With this in mind, we can interpret that dividing by x minus 4, and determining the remainder when we do so, would be the same as evaluating p of 4. This point on the graph shows 4 and 12, meaning p of 4 evaluates to give 12. Even without having the actual equation, I can know this to be true. Now we're asked to state the factored form of the equation for y equals p of x. We know that each x-intercept will correspond to a factor. Here we had a 0 at -2, so that will be a factor of x plus 2. We have a 0 at +2, so that factor will be x minus 2. And we have a 0 at +3, so x minus 3 will be a factor. It's important to note that we would normally have an extra step, which is that we would have to write a coefficient of a in front of all of this, and then use a point on the graph to determine its value. However, because this question is confirmed that the leading coefficient will be 1, we know that that a value would be 1, and do not need to perform those extra steps. Nonetheless, we will probably type our equation into our graphing calculator to confirm that x plus 2 times x minus 2 times x minus 3 gives us the same graph that we were originally shown.